Looking at the diagram, we are told that a force, a limiting frictional force, capital F, is 2000 Newton, pulling a body of mass 150 kilogram, and the frictional force is at an angle of 30 degrees, that is the small f. Then we are also having the reaction that is pulling the body down on the horizontal surface, which is reaction of 150 times 9.8 acceleration due to gravity, which will give us 1470 Newton. Solution. Angle of friction we are given to be 20 degrees. To get mu, we see that tan theta is equals to mu. Therefore, tan 20 is equals to mu, which will now give us 0.36. Limiting frictional force minus resistance force will give us MA. The force, because limiting frictional force is resisted by the opposing frictional force, which is the small f. If we minus it, we now get the real force we are looking for. Then we also have, we now get, if we substitute the frictional force, that is mu r, we now have the limiting frictional force minus mu r will now give us ma. If you are substituting the values, we putting in the values, the frictional force is 2000 Newton. The mu minus mu, which is 0.36 times normal reaction, that is the force that is keeping the body on the horizontal plane, which is 1470 Newton, which is now equal to mass, which is 150 times acceleration, which we are looking for. Then we now have the value after the computation, which we now have 2000 minus 519.2, which is equals to 150 A. Then if we minus the values, we now have 1470.8 is equals to 150 A. Therefore, making A the subject of the formula, we now have 1470.8 over 150. A will now give us 9.8 meters per seconds. A body of mass 10 kg is hung over a pulley that will pull a body of mass 12 kg along an inclined plane at an angle of 30 degrees. We are asked to get the acceleration of the body of mass 12 kg and the tension and acceleration of the body pulling down the body of 10 kg and the tension. We also know that the mass or the force of gravity is mass times acceleration for the body 10 kg, while that of acceleration due to gravity for the 12 kg body is mg sin theta, since it is acting on an inclined plane. Resolving the force for the body of mass at an inclined plane, 12 kg is being hung on a pulley by a tension T, where the acceleration A, which is unknown, along a horizontal surface mg sin theta. Force we know is equal to mass times acceleration. Tension of the body of the rope minus the force of gravity, which is mg sin theta, is now equal to ma. The tension on the rope minus 12 times 10 sin 30 is equals to 12a. that is mass of 12 times A. Therefore, T minus 60 is equals to 12A. T minus 12A is equals to 60 will be taken as our equation 1. Resolving the force for the 10 kilogram mass, we know that the tension T is pulling the body up, while that of the force of gravity mg will be greater to pull the body down with an acceleration of unknown acceleration. So mg, which is the force of gravity, will be greater than tension, which will be minus by the tension, will be equal to the force ma required to pull the body down the inclined plane. Substituting the values, putting in the values, we now have that 10, which is the mass, times 10, which is acceleration due to gravity, minus T, which is the tension, is equals to 10, which is the mass times acceleration. 1000 minus T, which is the tension, is equals to 10A. Then 10A, making the unknown values be on the one side and the known values to be on the other side, we have 10A plus T is equals to 100 is equals to 100. Now, solving for this will be our equation 2. Then, using substitution, using elimination method to solve the simultaneous equation of equation 1 and 2, we now minus the tension and now have minus 22A is equals to 4. Therefore, A is equals to minus 22A is equals to minus 40. Therefore, A is equals to 40 over 22, which will now give us 20 over 11. Then, putting in the value in equation 1, substituting back the value into equation 1, I have that T minus 12A is equals to 60. T, that is the tension, minus 12 times 20 over 11 is equals to 60. Therefore, T is equals to 12.5 plus 60, which we now have T. We now get our T to be 81.5 Newton. We can also get our acceleration. For only acceleration, F is equals to ma. We have that 100 minus 60 is equals to 22A. Therefore, our A is equals to 40 over 22. Question 14. A body of mass 10 kg is being hanged over a pulley to be dragged up by a body of mass 15 kg down an inclined plane at an angle of 60 degrees. We are not given the acceleration, we are asked to look for the tension. Then, looking at resolving the force on the 15 kg mass on an inclined plane of 60 degrees, we now know that since the body of mass is greater and it is on an inclined plane, the body seems to be sliding downwards the plane, and the acceleration will be downward. Then force is equals to ma. The tension, which will now be greater than the force of gravity, which is mg sin theta, will now be minus mg sin theta to give ma. Then T minus 15 times 10 sin 60 will now give us 15, which is mass, times acceleration. T, which is the tension, minus 130 is equals to 15A. Putting the